In this lesson, we're going to take a look at negative exponents. In order to understand the general rule for exponents that are negative, we're going to take a look at a pattern. First of all, we have 2 to the third, and we know 2 to the third is 8, and we know 2 squared is 4, and 2 to the first is 2. Back when we were working with exponents at the beginning of the year, we learned that any number other than 0 raised to the 0 power is 1. Notice there's a pattern going on here. 8 divided by 2 gives us 4, and that makes sense because we have one less power of 2 here. And then if we take 4 and divide it by 2, we'd have 2. And 2 divided by 2, we'd have 1. So if we continue with this pattern, 1 divided by 2 will give us 1/2. So 2 to the first power is 1/2. And if we continue with this power and divide by 2 again, we would see that 2 to the negative 2 power is 1/4. One way to think about this is to realize that 1/4 is the same as 1 over 2 squared. So basically, if you want to make the exponent positive, you just put that exponent in the denominator. So in general, a to the negative n power is the same as 1 over a to the positive n power. Let's take a look at some examples. But before we do that, let's just review some exponent rules. And we learned about these at the beginning of the year. If the base is the same, b to the m power times b to the n power, we add the exponents. If we have a quotient, instead of adding the exponents, we subtract them. Notice that the bases have to be the same. We have b as our base in both the numerator and denominator. Here we have a power to a power. So when we have a power to a power, we multiply the powers. So here we'd have b to the m times n power. Here we have a product raised to a power. So we're going to apply that exponent to both of the factors inside the parentheses. So we're going to have a to the m power times b to the m power. And then here we have a quotient, and just like when we had a product raised to a power, when we have a quotient raised to a power, we're going to apply that power to both the numerator and denominator. So a over b to the m power is the same as a to the m power over b to the m power. Now we're ready to take a look at some examples. Let's start with 10 to the negative third. Well, we said that if you have a to the negative n power, that's the same as 1 over a to the n power. So what I want to do in this example, is rewrite 10 to the negative third power as 1 over 10 to the third. And then we just have to realize that 10 to the third is 10 times 10 times 10, which would be 1,000. So 10 to the negative third power is the same as 1 over 1,000. 5 to the negative 2 power, that would be the same as 1 over 5 squared. To make the exponent positive, we put that in the denominator. And we know that 5 squared is the same as 25. So this would be 1 over 25. And here we have here we have 16 to the negative 1. So that would be the same as 1 over 16 to the first, or we can just say 1 over 16. Let's take a look at some other examples here. Here I'm going to first of all realize that we have an understood exponent of 1 here. And we have a quotient here, so I can subtract my exponents. So this would be the same as 5 to the 1 minus a negative 3, which would be the same as 5 to the 4th, since 1 minus a negative 3 is 4. And 5 to the 4th is the same as 5 times 5 times 5 times 5, and that would be 625. Here we're going to use the power property of exponents. When we have a power to a power, we multiply the powers. So this is just going to become b to the third. So in this case, since we have a negative times a negative, we get a positive exponent. Here we need to apply the 2, the square, to both the 3 and the x to the negative 1. So we're going to have 3 squared, which is 9. Then we're going to have x to the negative 2. And if I want to make that exponent positive, I'm going to rewrite that as an x squared in the denominator. Notice the 9 still stays in the numerator. The 9 is no longer impacted by the exponent. We actually already squared the 3 to get that 9. The negative is only impacting the x here. Let's take a look at a few other examples. Here, notice this is kind of similar to the previous example, but here the 3 is inside the parentheses, and in this example it is not inside the parentheses, so the 3 is not going to be squared. Only the x to the negative 1 is going to be squared. Power to a power, we multiply those powers together, so we have 3 times x to the negative 2, and then to make that exponent positive, we would put that in the denominator. So this is 3 over x squared. Here, let's see if we can rewrite the numerator first. Since these bases are the same, I can add the exponents. We'd have 5 to the second power in the numerator, and we'd have 5 to the third power in the denominator. And we can see that we have more 5's in the denominator than we do in the numerator by 1. So our final answer is going to be 1 over 5 to the first, or we can just say 1 over 5. If you didn't realize that and you actually subtracted the exponents, you would have had 5. You would have had 5 to the 2 minus 3, 5 to the negative 1, and that would become 1/5. Alright, this example looks a little more complex. Let's see what we can do here. First we'll apply the power to a power, multiply those powers together. So we'll have 4 to the 6th, since we have negative 2 times negative 3. Then we'll have times 3 to the negative 6, being careful with our signs here, all over 3 to the 4th times 4 to the 3rd. Alright, let's start with the 4's here. 4 to the 6th and the 4 to the 3rd. 4 to the 6th divided by 4 to the 3rd will be 4 to the 3rd. If we subtract the exponents. And now let's focus on the 3 to the 4th in the denominator and the 3 to the negative 6 in the numerator. If I think about it, the 3 to the negative 6, I could make that become a 3 to the positive 6 if I put that in the denominator. So then in the denominator I'd have 3 to the 4th times 3 to the 6th. And we know that if the bases are the same here, when we have this product, we can add the exponents. So our final answer is going to be 4 to the 3rd in the numerator and 3 to the 10th in the denominator. Okay, we have 2 other examples to finish up here. This one I kind of like. It's somewhat interesting. We're going to apply the negative 1 exponent to both the 5 and the 9. The other thing you might want to try to do on your calculator at some point is there's a reciprocal button. It has like a -1 key on it. You might want to see what happens if you were to actually type 5/9 and then hit the reciprocal button. We'll talk about this in class. In order to make a negative exponent positive, we put it in the denominator if it's in the numerator. And if it's in the numerator, we put it in the denominator. And if it's in the denominator, we put it in the numerator. So if you think about it, if I have a fraction to the -1 power, it's simply saying just take the reciprocal. Alright, let's take a look at this final example. Any number to the 0 power is 1, so I'm going to have 1 to the -3rd. And then I'm going to have 2 to the 3rd. And 1 to any power is 1. And then 2 to the 3rd would be 8. Don't forget to do the survey at tinyurl.